So now that we have some idea of what the Bohr model is, we want to talk about electronic structure of atoms. What that just means is, where are electrons in the atom? Okay, and depending on the type of atom, it may be, there may be more places that it's allowed to be, right? But big picture for this video, we're talking about, and probably the next one, we're talking about where are electrons located in an atom. And we're going to talk about a way to write it out. How can we maybe it's kind of like the address for an electron. How can we write out in some notation where an electron is most likely? Okay, so I will say one issue or one kind of characteristic of the quantum nature of electrons. We said the word quantized earlier on. One issue is that there's always a little bit of uncertainty with where electrons are. Electrons behave just weirdly enough that we probably know where they are, but there's a little bit of a chance that it's not where we think it is, kind of. Like, we can't exactly specify and know and pick it out, okay? And the reasons for that are kind of beyond this class. But just know we're going to talk more about probably and probability. Okay? We're never going to say this is exactly where I know the electron is, but we're going to say it's 99% sure that this is where the electron is. Okay, so I just want to say that at the outset. And we're going to start with the idea of orbits like we talked about before. We said that there's a nucleus, and then there are these orbits that we're calling energy levels. And the energy will increase from the lowest level up to the highest level. Okay. What we're going to start to call these levels and these orbits are shells. Orbital shells are going to be what we've been looking at as the orbits or the energy levels. So here, think energy levels or orbits. Okay, so the correct term is going to be the shell. And the shell is going to tell us how far away is the electron from the nucleus. The shell tells us how far away is the electron from the nucleus. Okay, so we're looking at energy level 1 tells us it's this far away, right? Energy level 2 tells us it's this far away, or shell 2, shell 1, shell 2, shell 3 tells us that it is this far away. Okay, so it's just giving us kind of a distance from the nucleus. Shell 4 might be out here, shell 5 might be out here. Okay, so it's just telling us how far away, and essentially the relative energy, right? Relatively low energy down at energy level 1, relatively high energy at shell 3. So how far away is the electron from the nucleus. Then, once we know the distance, we kind of want to know what volume, it's a three-dimensional, so what volume can the electron be in? Like, we know how far away it is, but beyond that, where else might it be? Okay, once we get that far, how do I know where it is? So the next thing is called a subshell. And the subshells are where it gets just a little bit weirder. So this picture doesn't seem super weird. The next one is going to be a little bit odd. So the subshell is going to tell us what volume of space, subshell, the subshell tells us what volume of space is the electron likely to be found in. What volume of space is the electron likely, right, to be found in? That's kind of like probably, likely to be found in. Okay. So at first we're looking at this picture where we have spheres. So one option is going to be spheres. And this subshell is going to be called the S subshell. Okay. So the first option is what we call an S subshell. And S subshells look like spheres, right? They're like circles but three-dimensional. So we've got a lower level, right? A smaller sphere where we're not that far away from the nucleus. This would be like a 1s, right? Energy level 1 or shell 1. Like if I go up here, it'd be like this guy. This is number 1, close to the nucleus. But the volume is a sphere, meaning S subshell. The S subshell is going to be a sphere. So then if I get a little bit further from the nucleus, this is a bigger sphere. This would be like the 2s is this red part, right here. 2s is the red, so it would say, well, the electron probably is a little bit further from the nucleus, not near the middle. It's further from the nucleus, but it's still a sphere that it's probably in. And then as I get even further from the nucleus, right, the nucleus is just at the middle there. This is going to be a 3s. 1s is down here, 2s, 3s. And you kind of have the separation between them that tells us the difference. Okay, so the 3s, if we think it's in a 3s subshell, I'd say it's somewhere here in the third orbit in this spherical kind of volume. Okay, so the shell tells us how far away from the nucleus it is. The subshell is going to tell us the volume, and our first subshell that we're talking about is the S, which is going to look like a sphere. Now we're going to get into different subshells that don't have a spherical volume. They have kind of a weirder volume designation. Okay. So there are 4 types of subshells, and they're all listed on this figure. Subshell types. There are 4 subshell types. The first type is the one that we just looked at on the previous page. So this is, the first type is the S subshell. And it shows one sphere here, right? So the sphere looks the same along any one of these 3 axes, right? The sphere is completely, totally symmetrical. So here, what we're going to say is there is one orbital in the S subshell. Okay, this is what the one orbital looks like. We'll talk about orbitals again in a second, but there's one way to draw or to orient this sphere. The second type, if we kind of split these up, the second type is called the P subshell. And this one looks sort of like maybe dumbbells or a figure 8. Okay, where we have no likelihood of the electron being in the middle, right? It's completely empty. But there's the probability that the electron is on either side of this center point. Okay, so if we have a shape like this that's kind of like an 8 or dumbbells, right, there are going to be 3 ways that we can orient this in space. We can orient it sideways, we can orient it up and down vertically, right, or we can orient it front to back, right, coming out the paper at us. Okay, so there are 3 ways to orient this shape, and what that means is there are 3 orbitals in each P subshell. Okay, there are 3 orbitals. Each of these pictures, each of these is going to be called an orbital. And there are 3 in the P subshell type. Okay, 1, 2, 3. There's only 1 in the S subshell type, and then the next type gets even weirder, and there are more orbitals in that type. Then the next one, the third subshell type, is called the D subshell. D subshell. And these are a little bit, like, most of them look the same, kind of, right? They're like peas, but if we had cut them in half again. So it's kind of like a 4-leaf clover shape, maybe, right? There are 4 lobes. And 4 of them are just orienting that shape in the different possible ways, right? So we've got these ones where they are kind of sideways, right? But the blue and red, you don't have to worry about the blue and red, but they switch places. And then here we've got it vertically, right? It's up on end. We've got our 4 lobes here. The last one is weird, where we've got kind of this donut shape in the middle and then the 2 lobes on the top and bottom. You don't have to know these shapes. I would like you to know that S is a sphere and P are 2 lobes. Once we get here, I don't want you to have to worry about that. So all you have to know is that there's the D subshell. Generally looks like this, and that there are 5 of them. There are 5 orbitals in the D in each D subshell. Okay, 1 orbital in the S subshell, 3 orbitals in the P subshell, 5 orbitals in the D subshell, and then I told you there were 4 subshell types. The 4th one I don't have a photo of here because it gets even weirder. The fourth type, I'm just going to give you the info. You can Google it if you want, F subshell. The fourth type is called the F subshell, and there are 7 orbitals. We won't usually talk about them very much, and I'll show you why later on in chapter 6, but there are 7 orbitals in each F subshell. Okay. So again, I want you to be keeping this big picture in mind. We're talking about where an electron is, and at this point with subshells, we're talking about volume. The volume that the electron is likely to be found in. Because with all of these new terms and new ideas, it's easy to get bogged down and lost and totally confused, right? If you're not already, this can be totally confusing. Big picture is, where is the electron in the atom? And we're building up a structure to where we can start to write out an address for an electron. I can say it's in a 2s subshell, or it's in a 2p subshell. That'd be like, you know, kind of a middle distance from the middle, and it'd be in these two, you know, this area. So we're trying to put that all together. This last figure tells us, it kind of puts it all together for us. Okay. It gives us the shells, which tells us distance, right? Distance from the nucleus. And what it tells us is which subshells are available at different energy levels. Distance from nucleus, also energy level. Okay. The number of subshells that we have available at that particular level, right? So are we allowed to have S? Are we allowed to have P? Are we allowed to have D? And are we allowed to have F? Okay. And then this is just telling us the same thing that I just wrote out, SPDF. So what this is saying is, at the first energy level, right, closest to the nucleus, only one subshell is allowed, and that's the S. So there is no 1P, 1D, or 1F. Doesn't exist. Only 1S exists. Then as we get further from the nucleus, we get to energy level 2, or shell number 2, and there are 2 subshells allowed, right? Look, these letters match, or these numbers match up. The 2 that are allowed are the S and P. So there can be a 2S or a 2P subshell, but no 2D or 2F. That doesn't exist. Then as we move even further out, we have N equals 3. That's like, right, we have our first level, second level, third level. That's like this guy here. Further from the nucleus, we're allowed to have S, P, and D, but no F. Okay, and then the very furthest is N equals 4. That's the very furthest orbital from the middle, most highest energy, and we can fit all subshells there. So we can have 4S, 4P, 4D, and 4F. And in each case, all of these are spheres, all of these are figure eights, most of these are those 4-leaf clovers, and then we didn't talk about this, but you could Google the shapes for that if you want to. Okay. So we're going to start to put electrons into orbitals, and we'll be talking about how we do that and how we write that out in the next video.